Hello everyone, this is Mamtarika and today I am here with a new topic that is matrices. Before we get to know what is matrices, let us see who invented matrices and where it is applicable or where it is applied in real life. Matrices was invented by a great mathematician Arthur Kelly. He is also known as father of matrices. Later on, the true use or mathematical use of this matrices was done by another mathematician who is also a poet and musician, that is James Sylvester. So let us see, where do we apply or where are the applications of matrices? Basically, matrices are applicable in various fields like computer science, statistics, economics. In computer science, many of you might have heard about coding and decoding. Coding and decoding of data, it is a huge number of data, and all this data can be converted into matrices, can be fed in the form of matrices. Also, if you know electric circuits can also be solved using matrices. In Also there are few more examples, that is in fields of gaming and animations, in constructions. In constructions, so you can say we know architects construct buildings. They give various shape, or they change the outer view of these buildings, and to to give such outer view, or to change the outer view of buildings, they need to solve a large number of equations, and these large number of equations are solved by matrices. So now we know where matrices is applicable. Okay, so let us move on to our actual main topic, that is what is matrices. So matrix, in a simple language, you can say it is an arrangement of numbers. Numbers you can say in row form, or you can say in column form, right? Certain number of arrangement of elements or numbers in rows and columns. So you have m rows and n columns, is known as a matrix. So if you have m rows and n columns, then such matrix is known as an m cross n matrix, because it has m number of rows and n number of columns. Now, how do we denote? We basically denote a matrix by an alphabet, say A, and the notation or the matrix is always written in a square bracket form, right? As we know, determinant is a form written in between two straight lines, whereas matrix is noted, or the notation for matrix is given by two given, or it is a table of form in square bracket. Also there are few more notations, that is you can also write it in round bracket form, you can write it in curly bracket form, but mostly we use a square bracket form. So what is a matrix? A matrix in simple language it is nothing but arrangement of elements in rows and columns. Okay, let us see what are a type of matrices. Let us discuss few types of matrices. So first one is a row matrix. Row matrix, that is arrangement of elements in row form. Okay, remember for easier to remember it easily, horizontal form में अगर दिखाई देगा एक ही रो, तो वो होगा रो मैट्रिक्स. अगर हॉरिजॉन्टल फॉर्म में बहुत सारे एलिमेंट्स दिखाई देंगे तो वो हो जाएगा कॉलम मैट्रिक्स. अनदर टाइप ऑफ मैट्रिक्स इज अ कॉलम मैट्रिक्स, दैट इज इन वर्टिकल फॉर्म, एक ही टर्म में दिखाई दे. सो नाउ यू कॉल दिस इज वन रो and three columns, so you call this as three rows and one column. So when you have only one column, it is known as a column matrix. Okay, further, square matrix, that is number of rows and number of columns are equal. Now here you observe this is a 2 cross 2 matrix. So 3 cross 3, 4 cross 4, all such matrix where rows and columns are equal is known as square matrix. Next is a null matrix. Null matrix, that is a matrix whose all elements are 0, is known as null matrix. Now suppose we are given a matrix, say A. Now if you observe here, we have 3 rows and 2 columns, so this is a 3 cross 2 matrix. And if we now just interchange the rows and column places, that is if you obtain writing the rows into column form, we obtain a new matrix of 2 rows and 3 columns, right? This transformation here is known as transpose of a matrix. So if A is a matrix, then the transpose of a matrix is noted as A to the power a dash, or you can say A to the power T. That is known as transpose of a matrix. Another form of matrix, that is unit matrix. Unit matrix where the diagonal elements are 1 and the rest all are 0. Such type of matrix is known as unit matrix. We also call a unit matrix as an identity matrix. Right? Further, next matrix is symmetric matrix. Symmetric matrix, so excluding the diagonal elements, if you observe here, the place A12 and the place A21, those are equal. That is a matrix which satisfies a relation Aij equal to Aji. Such matrix is known as a symmetric matrix which satisfies. Whereas if you find a relation and matrix which is of the relation Aij equal to minus Aji, then that form of matrix is known as skew symmetric matrix. इस diagonal elements छोड़ के बाकी के जो elements में उसमें अगर A12 observe करोगे और यहाँ पे A21, there is a change in sign, right? Element, if you saw number same है but sign अलग है, so that is a relation Aij equal to minus Aji. Such matrix is known as skew symmetric matrix. Next, diagonal matrix. Diagonal matrix, that is diagonal elements, and other than diagonal elements all terms are 0. Only elements are present in the diagonal terms. Such matrix is known as diagonal matrix. Then we have a scalar matrix. Scalar matrix, it is just like a diagonal matrix, but all the elements in the diagonal are 0. In the diagonal place are, in the place are same. Such matrix is known as scalar matrix. Next is upper diagonal matrix. Upper diagonal matrix, diagonal के ऊपर elements present है, whereas diagonal के नीचे के सारे elements क्या है, 0 है. Such form is known as a upper diagonal matrix. इसका ही just उल्टा होगा lower diagonal matrix. That means diagonal के नीचे elements present है, whereas above उसके सारे elements 0 है. Such elements or such diagonal matrix is known as a lower diagonal matrix. Okay, so these are the few forms of matrices. Now, with respect to transpose of a matrix, we need have some properties we could remember that can be where there's a helpful in point of view of your competitive exam. GATE में पूछा जा सकता है exam के लिए. So the first property says the transpose of a transpose matrix is an original matrix. Means A का transpose लोगे और उसका फिर से एक बार transpose लोगे, you get back a same original matrix. Right? Second one says suppose you take product of two matrices A and B, and if you take a transpose of that matrix, then that matrix is equal to the product of B transpose into A transpose. Okay. One more property you can remember, that is A plus B. That is, this one is with respect to product. With respect to addition, if you add two matrices and take transpose, then it is equal to A transpose plus B transpose. Okay, so these were a few type of matrices we had seen. Now let us see what is a determinant of a matrix. We all know determinant. Determinant, it is nothing but an arrangement of certain numbers in rows and columns, but it is noted in two straight lines. So a matrix can also be written in a determinant form, but here we know a square matrix particularly. Right? So suppose this is your given square matrix, then the determinant form of this matrix will be in nothing but in all the same elements written in two straight lines. Okay. Further, what is a minor of an element? Minor, a square matrix, we calculate the minors from the determinant matrix, right? Determinant form. So once given a matrix, we can convert it into determinant form, and then from this determinant form we can calculate a minor. Minor is nothing but the value of an element which is obtained by eliminating, or which is nothing but a determinant and we obtained by eliminating the row and the column of the particular element. So suppose here you have given a matrix, a determinant A, and if you have to calculate the minor of element 1, so minor of 1, that is A11, क्या हो जाएगा? To calculate this minor, we will neglect the corresponding row and the corresponding column, and जो elements बचेंगे उसका determinant लेगी. So determinant यहाँ पे क्या होगा? 3 minus 1, 1 and 2. So इसका determinant value हो जाएगा 3 2s are 6 plus 1, that is 7. Similarly, we can calculate minors of all the elements present in this square term. So suppose now we have to calculate minor of, say, element is minus 1. So this is minus 1 is nothing but at a place A32, that is minor of A32 element. So what do? We will neglect the corresponding row and the corresponding column, and then we will find a determinant of the remaining terms. So 1 3 2 1. Determinant क्या होगा? 1 minus 3 2s are 6, that is minus 5. So such is in such manner we calculate minor of A, given matrix A. Suppose further we have to calculate cofactor. Cofactor क्या होता है? Cofactor nothing but again minor ही होता है, but with some sign, with proper or be associated with proper sign. So cofactor of a matrix you can write, or cofactor of an element aij can be formulated as minus 1 raised to I plus j minor of ij term. So suppose you are given the same matrix, we write the determinant form. Now suppose you have to find a cofactor of this one place. So cofactor of A11, you can also denote it as Cij, or you can also write it as Cf of A11, not an issue. All these terms or these notations are valid. So उसका cofactor क्या होगा? By this formula it will be minus 1 raised to 1 plus 1 into minor of A11. So minus 1 raised to 2 is going to be positive, and minor of A11 so हमने already find out किया है, so it is going to be 7. Suppose you have to find a cofactor of, again जो हमने यहाँ पे minor find out किया A32, उसका ही अगर cofactor find out करना है, suppose CF of A32. So according to this formula क्या हो जाएगा? ये होगा minus 1 raised to, sorry, this is 3 2. So ये हो जाएगा 3 plus 2 into minor of an element A32. So minus 1 raised to अभी ये 3 plus 2, that is going to be 5. Odd term है तो negative रहेगा, और minor क्या मिला है? Already हमें minus 5, तो ये हो जाएगा positive 5. And this will be, and accordingly we can calculate cofactor of each element present in this determinant. I hope everyone is clear. I hope it is clear with all what is determinant, minor and cofactor. So let us see now what is adjoint of a matrix. Adjoint, that is nothing but transpose of cofactor matrix. Cofactor matrix तो हम सबको पता है. Cofactor matrix मतलब a matrix formed by calculating the cofactors of all the elements. That matrix is known as a cofactor matrix, and cofactor matrix का जब हम transpose लेंगे तो वो हो जाएगा adjoint of a matrix A. So now let us calculate for the given matrix. So for this matrix we can write the determinant form. Determinant form क्या होगा इसका? 1 2 3 2 3 1 1 minus 1 and 2. Okay, so ये हो जाएगा determinant form. अभी ये determinant form मिल गया. We can calculate the cofactors of each element. So one by one we will calculate all the cofactors. So that we obtain the cofactor matrix. तो cofactor of 1 क्या होगा? वन पर्टिकुलर रो और कॉलम को एलिमिनेट करके जो डिटर्मिनेंट रहेगा उसके जो टर्म्स रहेंगे उसका डिटर्मिनेंट वैल्यू विथ करस्पॉन्डिंग साइन। अभी रिमेंबर और साइन कैसे याद रखोगे, दिस इज A11 A12 A13। तो इसीलिए याद रखने के लिए क्या करो, अल्टरनेटली पॉजिटिव नेगेटिव इस फॉर्म में याद रखो। सो कोफैक्टर ऑफ 1, कोफैक्टर ऑफ 2, कोफैक्टर ऑफ 3, ये हो गया फर्स्ट रो। सेकेंड रो में क्या हो जाएगा, कोफैक्टर ऑफ 2, देन कोफैक्टर ऑफ 3 एंड थर्ड कोफैक्टर ऑफ 1। थर्ड रो का क्या मिल जाएगा, कोफैक्टर ऑफ 1, कोफैक्टर ऑफ -1 एंड कोफैक्टर ऑफ 2, राइट। तो A11 मतलब 1 + 1 2, तो ये पॉजिटिव, तो नेगेटिव, फिर से पॉजिटिव, फिर से नेगेटिव, पॉजिटिव, नेगेटिव, पॉजिटिव, नेगेटिव एंड पॉजिटिव। ठीक है, तो यह ऐसे जब याद रखोगे तो ये इजीली ये सॉल्व करते वक्त साइन में गलती नहीं होगी। अभी 1 बाय 1 माइनर कैलकुलेट करो। तो 1 का माइनर क्या होगा, ये छोड़ के जो यहाँ पे दिया है उस करस्पॉन्डिंग रो और कॉलम छोड़ के जो डिटर्मिनेंट बचेगा, जो टर्म्स बचेंगे उसका डिटर्मिनेंट। सो 3 to the 6 माइनस माइनस प्लस हो जाएगा, तो इसकी वैल्यू आ जाएगी 7। सेकेंड, अभी 2 का कोफैक्टर कैलकुलेट करना है, तो 2 का करस्पॉन्डिंग रो और कॉलम एलिमिनेट करेंगे और बचे हुए टर्म्स का डिटर्मिनेंट। सो ये होगा 4 - 1 दैट इज 3। फिर 3 का कैलकुलेट करना है, तो 3 का कैलकुलेट करने के लिए करस्पॉन्डिंग रो और कॉलम हटा देंगे, बचे हुए एलिमेंट्स का determinant. So determinant of this terms will be -2 - 3, that is -5. Then further for 2 again we will all the remaining terms we will carry on with the same process. So 2 का calculate करने के लिए corresponding row और column we will neglect. Then remaining terms will be 2 2s are 4 minus minus plus 3, that is going to be 7. So cofactor of 3. So eliminate the corresponding row and column. So corresponding row and column value eliminate. Remaining 2 minus 3, that is -1. Then while calculating the cofactor of 1, we will eliminate this row and column. So what will remain is 1 2 and 1 minus 1. So determinant of these elements will be -1 -2, that is -3. So it is going to be minus minus +3, right? Then cofactor of 1, third row, first element, corresponding row and column neglected. Then remaining terms 2 minus 6, so that is going to be -4. Further cofactor of -1, so neglecting the corresponding row and column, here it is 2, right? So corresponding क्या हो जाएगा, neglect करोगे तो 1 minus 6 minus 5. So minus of minus, this is going to be +5. Further last row, third row का last element, that is 2. So corresponding row and column eliminate हो जाएगा. Remaining terms will be 3 minus 4, that is -1. So now we have cofactors of all the elements. Now we will just put down it in a matrix form, and that matrix form is known as cofactor matrix. So what will be cofactor matrix? जैसे रो फॉर्म में लिखा है वैसे ही लिखते जाओ. So ये होगा 7 -3 -5 -7 -1 3, then -4 5 and -1. So now we have this cofactor matrix, and we now take the transpose of this matrix, and this transpose will give us nothing but a adjoint of a matrix. So therefore adjoint of a matrix क्या हो जाएगा? It is going to be transpose of cofactor matrix, right? So I directly write the transpose. Transpose मतलब क्या? रोज को कॉलम फॉर्म में लिखना है या फिर कॉलम फॉर्म को रो फॉर्म में लिखना है. सो रोज को कॉलम फॉर्म में मतलब 7 -3 -5, then minus 7, minus 1, 3, and then minus 4, 5, and minus 1. This is our required adjoint of a matrix, right? So now we know what is adjoint of a matrix. We know how to calculate determinant of a matrix. We can calculate the inverse of a matrix, right? क्या होता है inverse? What is inverse formula? Inverse of a matrix is nothing but adjoint upon determinant. Adjoint क्या होता है? It is nothing but transpose of a cofactor matrix, and we know the determinant. But when is inverse applicable? Inverse is applicable for only when determinant is not equal to 0. That is when it is a non-singular matrix. When determinant is equal to 0, we call it as a singular matrix. And when determinant is not equal to 0, we call it as a non-singular matrix. Correct? So now let us find the A inverse of the given matrix. So this is the same matrix which we have saw earlier. So इसका cofactor adjoint हमें पता है already. So I will just directly write down what is the adjoint matrix here. I'll write down the cofactor matrix, adjoint matrix, and we will get the A inverse. Also, but we need to know what is the determinant value. So we will calculate that one first. So determinant form, what is the determinant form? Determinant form is 1, 2, 3, 2, 3, 1, 1 minus 1 and 2. This is the determinant. How do we calculate determinant? First element and corresponding row or column eliminate karo, baki terms ka determinant. So it is going to be 1 into 6 minus of minus 1, that is plus 1. Then minus 2 times corresponding row and column neglected. So this is going to be 4 minus 1 and plus 3 times. Then corresponding row and column neglect karoge to minus 2 minus 3. So what will be the determinant? So this is going to be 7 minus, this is going to be 3 2s are 6 minus 5 3s are 15. So therefore determinant is going to be minus 14. Now we know determinant. We have already calculated the cofactor for this matrix. So what is cofactor? Cofactor per matrix for the given term is 7 minus 3 minus 5, then minus 7 minus 1 3, then minus 4 5 and 1. So iska transpose loge to we will get the adjoint matrix. So therefore adjoint of a matrix, or you can write it as adjoint of A, is nothing but 7 minus 4 minus 3 minus 1 5 minus 5 3 and 1. This is our adjoint matrix. So now we have adjoint, we have determinant. So therefore A inverse will be 1 upon minus 14 into this matrix, that is adjoint matrix 7 minus 4 minus 3 minus 1 5 minus 5 3 1. And this will be the inverse of given matrix A. I hope everyone is clear with this. So right now we have seen how to find A inverse, but if you observe, this is a bit lengthy process. So let us discuss a shortcut method to find inverse. Such type of examples are asked in competitive exam where you are asked to find inverse. Then instead of going for this lengthy process, we can go with the shortcut method. Let us discuss the shortcut method for the previous example itself. So the given matrix was A equal to 1, 2, 3, 2, 3, 1 and 1 minus 1, 2. Now we know what is A inverse. A inverse is nothing but 1 upon determinant of A into adjoint of A, and we need to find A adjoint of A. Adjoint of A we will find by shortcut method. Determinant of A we have already found out. We know determinant of A here is minus 14. Now, to find the adjoint of a matrix, instead of finding the cofactors, cofactor matrix, and then taking of transpose, we will go by shortcut. So what is the first step? We will take down the whole matrix as it is, whatever is given. So the given matrix 1, 2, 3, 2, 3, 1, 1, minus 1 and 2. Okay, now second step will be repeating the first and second column as it is. Besides, so first column 1, 2, 1 and the second column 2, 3, minus 1. We repeat the first and second column. Third step, we repeat the first row and the second row, the first and second row which we have newly obtained right now, that we will repeat and write it down. So here we go 1 2 3 1 2 2 3 1 2 3. Okay, so this is the newly formed matrix we have now. Now in this matrix, the next step will be eliminating the first row and the first column. So what is the first step? Take down the matrix as it is, then copy down the first and second column besides, and copy down the first and second row in the bottom, and then you will obtain a new matrix. In the new matrix, delete the first row and first column. Now in this matrix, we are remaining terms, we will find the determinant pairwise. So this will be the first determinant value we will obtain, second, third. Now remember, while we will calculate the determinant values in vertical form, whereas when we write it down, we will write it down in horizontal form. Calculating vertically, write it down in horizontal form. That will give us the adjoint of a matrix A. So one by one we will calculate. So the first term 3 2s are 6, minus plus 1, so this is going to be 7. Then minus 3 minus 4 minus 7, then 2 minus 6, that is minus 4. Calculating vertically, then go writing horizontally. Similarly, we'll go for the next part. Again, we will calculate horizontally here. So 1 into 1 minus 4, that is minus 3. Then 2 minus 3 minus 1, 6 minus 1, that is 5. Similarly, in the next third pairing terms, again minus 2 minus 3 minus 5, then 2 plus 1 3, and 3 minus 4, that is minus 1. So if you compare back, we had obtained the same adjoint matrix by finding the cofactors matrix or by taking the transpose of cofactor matrix. So isn't it easier? So we are now we have obtained the adjoint matrix, and therefore we can write down finally the A inverse term, and therefore A inverse is 1 upon minus 14 into the matrix 7 minus 7 minus 4 minus 3 minus 1 5 minus 5 3 minus 1, and this is the A inverse we have obtained by shortcut method. I hope everyone it is clear to all. Let us solve one more example. Let us solve another matrix, find A inverse for the same using shortcut method. So again for this matrix, now we know what is A inverse. A inverse is adjoint upon the determinant of matrix. So for this we need to know first what is the determinant value. We will calculate the determinant value. As we all know how to calculate determinant, the first term, then determinant of remaining, then minus the 8 1 2 term, then the determinant of remaining values. So it is going to be 1 times minus into minus 1 into minus 4. So this is going to be 4 plus 15, then minus 2 times, neglecting the corresponding row and column, so this is going to be 0 plus 12, and plus 3 times 0 plus 4. So when you calculate this is going to be 19 minus 24 plus 12, and therefore determinant value, what it is going to be, minus 19 plus 24 or plus 12, so it is going to be 7. So if you observe, the determinant value is a non-zero value, and therefore we can find a A inverse. Further, to find a A inverse, we need to know what is adjoint, and adjoint value we will find by shortcut method. So what is the first step? The first step is, first write down the matrix, given matrix as it is. 0, minus 1, minus 3, 4, 5, minus 4. Then the second step, copy down the first column and the second column besides this matrix as it is. So it is going to be 1, 0, 4, and then 2, minus 1, 5. Third step, copy down the newly formed row and to first and second row below. So this is going to 1, 2, 3, 1, 2, 0, minus 1, minus 3, 0, minus 1. This is the newly formed matrix we have. Now in this matrix, what we will do, we will neglect the first row and the first column, and then pairwise we will start writing the determinant. How do we find? We find vertically and write it down in horizontally, and that will be our required adjoint matrix. So one by one we'll carry on. This is going to be 4 plus 15, that is 19. Then 15 plus 8, that is 23. Then minus 6 plus 3, minus 3. Then in next pairings, minus 12, 0. So this is going to be minus 12. Then 4 minus 12, 4. Yeah, but sorry, this is minus sign here. So this is going to be minus 4, minus 12, that is minus 16. And then 0, minus plus 3. So this is going to be 3. Then here, again going pairwise, 0 plus 4, this is 4. Then 8 minus 5, that is 3, and minus 1. This is our adjoint, required adjoint of a matrix, and therefore A inverse is going to be determinant, that is 1 by 7, into the adjoint matrix, that is 19, 23, minus 3, minus 12, minus 16, 3, 4, 3, and minus 1. And this is the required A inverse. You can calculate it by solving or finding the cofactors and can verify if we get a C matrix. I hope the basics we had revised today, or have seen today, that is type of matrix, what is matrix, what is cofactor matrix, what is transpose, what is A inverse, all this is clear to you all. Thank you.